So we're going to get started with what you learned when you were in 8th grade or maybe 9th grade. And that's going to be a basic trinomial with a leading coefficient of 1. 1x squared plus 9x plus 20. Trinomial, 3 terms. What you will do here is you're going to take the a times the c. A times c is positive 20 combined to give you a positive 9. This tells you they're going to be the same signs. How do I know if they're both positive or both negative? It's all based on this term. They're both going to be positive. Do I know 2 numbers that can multiply to give me positive 20 and combine to give me 9? I sure do. 4 and 5. I write down my a. I write down my c. Now in the middle, I'm going to write down the 2 values that I came up with, which was positive 4 and positive 5. Whatever variable is behind the b, sometimes it's an x, sometimes it's an x squared, whatever variable is behind the b is going to be attached behind each one of these. I'm underlining the first 2. What can I divide out of these? I can divide out a 1x. What am I left with? 1 divided by 1 is 1. I need 2 x's, and I need to attach 1 more. 4 divided by 1 is 4. I need 1x. I already have the 1x when I distribute. I'm going to take what's in parentheses, I'm going to place it in back and put a little question mark here in front. What times 1x gives me a positive 5x? That value is positive 5. Now when I distribute it, I still need to come up with this, in this case, a positive 20. There's a front and a back. They both contain a 1x plus 4, which is the same as x plus 4. In front of the first parenthesis is 1x, and in front of the second parenthesis is a positive 5. Let's see one more of these really simplistic trinomials. I'm going to come off to the side. I'm taking a times c to equal negative 4, and I have to combine to give me a negative 3. This tells me this time they're going to have different signs. One's positive and one's negative. This tells me the sign of the larger number, so the larger number is going to be negative. What 2 numbers multiply to equal 4 and combine to give us a negative 3? That's 4 and 1. The larger number is negative. Negative 4, positive 1. I write down a, I write down c, and in this missing part is a plus 1x and a minus 4. Whatever variable is behind the b is attached to those values, in this case 1 and negative 4. By the way, a great question I've been asked in the past is, how do I know whether to put negative 4 first or positive 1? It doesn't matter. In the end, you'll get the right answer as long as you keep the algebra straight. What can I factor out? A 1x. 1 divided by 1 is 1. I need 2 x's, attach 1 more. Positive 1 divided by 1 is 1. I need 1x. I already have it. We're writing 1x plus 1 and back. What value times 1x is negative 4? That would be a negative 4. Negative 4x and negative 4. I have a front and a back. They both contain a 1x plus 1. In front of the first is 1x. In front of the back is a minus 4. This is the same as x plus 1 and x minus 4. Concepts are still at the Algebra 1-2 standard level, but let's review, because what's different now is the leading coefficient is not a 1. I'm taking a times c equals a negative 12, and my b is negative 1. This tells me they are different signs. One's positive, one's negative, and below tells me the larger of the 2 numbers will be negative. What multiplies to equal negative 12 and combines to equal negative 1? That's a 4 and a 3. Larger number is negative. So I come over, I write down the a, I write down the c, and now I drop these in. What goes behind them? It's going to be the variable of the b, so it's an x and it's an x. I'm underlining the first 2. What is the maximum that I can divide out? I can divide out a 3. I can also take out 1x. 3 divided by 3 is 1. I need 1 more x. 3 divided by 3 is 1. I don't need an x because when I distribute, I already have the 1x. By the way, as soon as you get on to your second paper, which happens to be pink, problems like this where the leading coefficient is not 1, you can use a calculator. I'm going to take this parenthesis and I'm going to copy and paste it in back. If this trinomial is factorable, I'm going to be able to come up with a value that when I take it times 1x, I end up with negative 4x. And that value is negative 4. Negative 4x, and when I distribute, I still get a negative 4. The front and the back both contain a 1x plus 1, which is the same as x plus 1. In front of the first is a 3x. In front of the back is a minus 4. Before I get started with these, I do want to review for you difference of squares. So you're welcome to watch these or write these down, totally up to you. Okay, perfect squares, 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6, and so on. These are all examples of expressions in which we can quickly factor using the concept of difference of squares. Now, in order to do this, one thing has to happen. We have to have subtraction in the middle, otherwise we can't use this. And we have to have a number in front and a number in back that are perfect squares. So 1 is a perfect square. It splits into 1 and 1. 9 splits into 3 and 3. And I have subtraction. Lastly, I have to be able to take this x and evenly split it into 2. When that happens, then I can quickly factor this using the difference of squares. 1 in x's comes from the front. 3's come from the back. 1 is positive and 1 is negative, and we're done. Algebra 1, 2. Here we go. 4 is a perfect square. 25 is a perfect square. This splits into x and x. And because I have subtraction, you can't move forward if you don't have subtraction, 2 x's come from the front, 5's come from the back, 1 is positive, 1 is negative. Why can I not take the third expression and do the same thing? Because this breaks into 4 and 4, this breaks into 1 and 1, this breaks into x and x. Why can I not move forward? It does not have subtraction. It can't be broken apart like that. Last one, we have 6 and 6, 5 and 5, x and x. And because I have subtraction, the 6x's come from the front, the 5's come from the back. One of them is positive and one of them is negative. Okay, we're going to use that concept as we go on to our next problem. Here is our next problem. Please write down 2x to the fourth minus 7x squared minus 4. We have a trinomial. Although the degree of this problem, the highest exponent on a variable is a 4 instead of a 2. We still have a trinomial. So I'm going to check to see, can I factor it? A times c is negative 8. The b is negative 7. This tells me the two signs are going to be different. This tells me the larger of the two numbers is going to be negative. So do I know two numbers that multiply to give us 8 and combine somehow, negative 8, and combine somehow to equal negative 7? I do. 8 and 1. 8 times 1 is negative 8 if they're different signs, and I can achieve a negative 7 combining them. But the 8 must be negative. These two multiply and combine. So what do? I start by writing down the a, and I write down the c. But this time when I drop in the values negative 8 and positive 1, I have to go back up to the b and notice that the b doesn't contain an x, it contains an x squared. Okay. Out of these first two terms, it's just like what we've been doing. What's the most I can factor out? A 2x squared. Remember, this is 4x's and this is 2x's. So I factored a 2x squared. 2 divided by 2 is 1. I need 4x's. That means I need 2 more. Negative 8 divided by 2 is negative 4. I need 2x's, and I already have them. In back, I'm going to write down the 1x squared minus 4 with a little question mark in front. If I can continue to factor this, I'll be able to come up with a value that when I take it times 1x squared, I get 1x squared. Well, the only number we could use is a 1. 1 times 1x squared is 1x squared. 1 times negative 4 is negative 4. They both contain a 1x squared minus 4. In front of the first part is a 2x squared, and in front of the back part is a positive 1. Why am I not done? Because 1 is a perfect square, 1 times 1. 4 is a perfect square, 2 times 2. X can split into x and x, and I have subtraction. That means that this parenthesis breaks into 1x plus 2 and 1x minus 2. Don't forget about the 2x squared plus 1 in back. Now we're going to go back to cubes. Remember, 1 times 1 times 1. It's how we started off with learning factoring about 2 weeks ago. So let's start with this one. 8x cubed plus 1. From 2 weeks ago. Now this was brand new for you, whether you had Miss Castro or not. Remember, 8 breaks in, it's a perfect cube, 2, 2, 2. X cubed breaks into x, 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 and 1 breaks into 1, 1, 1. With cubes, you can do it regardless of having a plus or a minus. As a reminder, the first parenthesis always has 2 terms, the last parenthesis has 3, and this is always going to be addition. Now this particular expression starts with addition in between, and so in this missing piece, we're going to put subtraction. I'm grabbing 1, 2, and 1x, they're going to go in front, and 1, 1 goes in back. In the front of the second parenthesis, 2 times 2 is 4, x times x is x squared. I'm done with all the front pieces. 1 times 1 in back, you're multiplying, not adding them. And then this missing term, we already know it's going to be subtraction, is we're going to multiply these two. 1 times 2x is 2x. Sometimes it disguises itself. So sometimes, I'm not going to do this whole thing, but let me just show you. Sometimes it looks like this. And you may think, there's nothing I can do. Like 16 and 2, they're not perfect squares. But notice that 16 and 2, you could factor out a 2 and you get 8x cubed plus 1, 16x cubed plus 2. And then you'd get the exact same thing in the end. The only thing you had to initially do is first factor out that 2, and then you could proceed with the sum or difference of cubes.